Today we're going to talk about polynomial functions and graphing polynomial functions. There seems to be an awful lot of information here. It really isn't that bad. It probably will take about a minute, maybe a minute and a half to copy it down. So pause the video, copy it all down, and then come back and we'll go through it. All right, now that you have it all copied down, let's go through and see what you actually copied down so that you understand what you wrote. A polynomial function is a continuous function that can be described by a polynomial equation in one variable, meaning you only can have one variable throughout the equation. The variables can be raised to a lot of powers, but you can only have one variable. Once you have more than one variable in the equation, it's not considered to be a polynomial function. Standard form of a polynomial function is when the values of the exponent are in descending order. So for example, squaring would come first, the variable without an exponent comes last, and then the integer that it doesn't have a variable would come on the end. So you want to make sure your exponents go in descending order from highest to lowest. For an example, 3x to the third minus 4x plus 6 is considered to be in standard form because the highest exponent, 3, came first. The degree, now this is important, the degree of the polynomial is the value of the greatest exponent. So if the actual polynomial is in standard form, then your greatest exponent should be the first exponent, and then that will be the degree of your polynomial. The coefficient of the first term of the polynomial in standard form is called the leading coefficient. So your leading coefficient, as long as your polynomial function is in standard form, would be the first term. You would use substitution to evaluate the polynomial functions and function values of variable. Okay, let's take a look at number 1a. Number 1a says, state the degree and the leading coefficient. Just so that you don't have to write leading coefficient all the time, we're actually going to abbreviate leading coefficient as L period C period. Of each polynomial in one variable. If it's not a polynomial in one variable, explain why. Well, let's take a look at letter A. First of all, does it have one variable? It does, so it is a polynomial. Is it in standard form? Are the exponents in descending order? You are right, they are. So, we want to know the degree and the leading coefficient. So the degree in this case would be the highest exponent, which would be 5. So it's a degree 5 polynomial. And the leading coefficient, the LC in this case, would be an 8 because it's the first term in the polynomial, which is in standard form. It's kind of easy, isn't it? Okay, with that being said, let's move on to a couple more. Letter B. First things first, is it considered to be a polynomial? And you're right, it's not. It's not a polynomial. So let's write that down. Not a polynomial. Does anyone, I'm making sure I can spell correctly, polynomial. Does anyone know why it's not a polynomial? You are right, because it has two different variables. So because it has two different variables. It's got an x and a y, and you can't have an x and a y. You could only either have all x's or all y's. All right, let's take a look at letter C. Is letter C considered to be a polynomial? Yes, it is, because it only just has variables of an x. Is it in standard form, though? No, it's not. So we need to get it in standard form. So remember, it's got to go in descending order of exponents. So I'm going to rewrite it as negative 4x to the 8th. Next would come plus 3x to the 4th. Then would come plus 6x cubed plus 2x. Okay, now that it's in standard form, what degree would it be? You are correct. It's a degree 8. And what would the leading coefficient be of this polynomial? You are correct. It would be a negative 4. Okay, with that being said, let's go on to number 2. Number 2 says, find w of negative 4 if w of x is the following. So it actually is a function, and we're really good at functions because we just finished that unit. So we're just going to actually plug in negative 4 everywhere I see an x. All right, so here we go. Whoops, need to put my pencil back on. 2 times negative 4 raised to the fourth. Do you see how I'm encasing that -4 in parentheses? It's very important that I'm doing that. Minus 5 times -4 cubed plus 3 times -4 squared minus 2 times -4 plus 8. Take out your calculator, plug it all in just the way you see it with the parentheses and everything. Pause the video and then come back and see if our answers match. Did you end up with -247? If you didn't, double check. Did you encase -4 in a set of parentheses each time you plugged it in? Because that's very important. When you raise a negative to a power, it's got to be encased in parentheses. All right, with that being said, let's move on to a couple more examples today. The volume of air in the lungs during a 5-second respiratory cycle can be modeled by the following function, where V is the volume in liter and T is the time in seconds. Using this equation, find the volume of air in lungs 2 seconds into the respiration cycle. So we basically want to find V of, you're right, V of 2. So everywhere we see a T, we're going to put a 2. Okay, so negative 0.03742 cubed plus 0.152 parentheses 2 squared plus 0.173 times 2. All right, take a minute, put in your calculator, let's see what you got. Hopefully you ended up with, I ended up with 0.6548. Any questions on that? If you were able to make it a fraction, go right ahead. Let's take a look at number 4, though it's not necessary to make that one a fraction since the equation had decimals in it, so we're okay to leave it as decimals. With number 4, they want me to find c of y cubed. If c of x equals 4x cubed minus 5x squared plus 2. So everywhere we see an x now, we're going to put a y cubed. All right, here we go. C of y cubed is going to be 4 times y cubed cubed. See how it's going to have a double exponent? Minus 5 times y cubed squared plus 2. All right, the first thing we're going to need to do is get rid of those double exponents because it's power to a power rule, so we're going to multiply the exponents. So we have 4 times y to the 9th minus 5 times y to the 6th plus 2. So now we got 4y to the 9th power minus 5y to the 6th power plus 2. Can we combine any like terms? No, because they don't have like exponents. So we're done. And that ends our video for today. See you in class tomorrow.